Hello everyone, welcome back to the session on complex integration. Myself Dr. Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to the today's session on complex integration. So today I am going to solve some problems on line integral of a complex variable. So we know that the complex variable z is in the form of x plus iy, and the complex function of complex variable will be in the form of u plus iv. So evaluating the line integral of a function of complex variable along a curve C is simply evaluating this u plus iv, the function multiplied by u plus iv and dx plus idy. Since z is x plus iy, we can find dz as dx plus idy along the curve C. So here the line integral means with respect to one variable only we can evaluate the integral. So in the resultant of this function we will have both variables x and y. So either we need to transform x to y or y to x or both x and y in terms of a new variable t, theta, etc. So in the last session we have solved two problems, and again in today's lecture I am going to continue the same. So let us solve the problem. Evaluate the line integral of the given function along y equal to 3x between 2 points origin over 0, 0 to a 3, a. So given y equal to 3x, that implies we can replace y by 3x in the given integrand. Now here we have dy also. So differentiating on both sides, dy becomes d3 dx, and we need, so that means we can write completely y in terms of x, and hence finally we get an exclusive function in terms of x. So we need the limits of x 0, 0 to 3, a. So here x equal to 0, x varies from 0 to 3. So therefore the line integral along C x plus y dx plus x square y dy is same as evaluation of x from 0 to 3, x plus, we can replace y by 3x. So x plus 3x dx plus x square into y again 3x, dy is 3 dx. So we have to integrate this entire function. Now this is equal to integral x from 0 to 3. Let us multiply x dx or x plus 3x, which is 4x, plus 3 into 3 9, 9x cube dx. So simply by integrating we get 4x square by 2 plus 9x power 4 by 4 from 0 to 3. So we need to apply the limits. So here 2 times. So 2x square, that is equal to 2x square plus 9 by 4 x cube from 0 to 3, 9 by 4 x power 4, and limits are from 0 to 3. Now applying the upper limit, this is 2 times of 9 plus 9 by 4 into x power 4. So 3 power 4, that means 3 power 4. And the lower limit 0, since the lower limit x is 0. Now this is 18 plus 9 by 4 into, so 3 square is 9, 3 cube is 27, 3 power 4 is 81. So this is 18 plus 9, 729 by 4. So by taking LCM, 40 plus 32, 72 plus 729, which is, so 1 here, 801 by 4. Hence the line integral is equal to 801 by 4. Now let us solve one more problem on the line integral of a function of complex variable. Here evaluate a integral x square minus iy dz where the limits are 0 to 1 plus I, means z1 to z2, along the paths y equal to x, a straight line, y equal to x square, a parabola. So here two different paths are given. So we need to evaluate this line integral in both cases. So we solve the problem in two different cases, one by one. First along the straight line and then parabola. Now first we have z equal to x plus iy. So that implies dz is dx plus I dy. And now coming to the first one, along y equal to x. What is this y equal to x? It's a straight line passing through origin. So this is the line y equal to x. Now what are the given limits? Given z equal to 0 to z equal to 1 plus I. But what is z? X plus iy. So z equal to 0 means x plus iy is 0. So x is 0 and y is 0. Similarly, z equal to 1 plus I. That implies x plus iy is 1 plus I. So x equal to 1, y equal to 1. So the points are origin 0, 0 and some a 1, 1. In the first problem, we need to replace y by x. Y is equal to x. That implies dy becomes dx. And we are writing everything in terms of x. Hence, we need x limits. Here x is 0, here x equal to 1. So x changes from x equal to 0 to x equal to 1. So we need to evaluate the line integral from x equal to 0 to x equal to 1, and we write the integrand completely in terms of x. So therefore, the line integral 0 to 1 plus I, x square minus iy dz is equal to x square minus, what is y? Y equal to x and dy is dx. So minus ix into dz is dx plus I dy. So x will be as it is, dx as it is, I dy is again dx. So x square minus ix into 1 plus I dx. Now simplify this. Everything is in terms of x. So along the given curve, here x from 0 to 1. So x equal to 0 to 1. Now multiply x square plus x square I minus ix minus I square x dx. On simplifying this, we get here x square, the real part, I square is minus 1. So plus x, again the real part, plus, now I common, x square minus x dx. Now split this integral into two parts, 0 to 1 x square plus x plus I into 0 to 1 x square minus x dx. So that is equal to the first one here dx. First one, integral of x square is x cube by 3 plus integral of x is x square by 2 from 0 to 1 plus I into x square x cube by 3 minus x square by 2 0 to 1. So applying the upper limit 1 by 3 plus 1 by 2 plus I into 1 by 3 minus 1 by 2, and lower limit is completely 0. So this is 6 LCM. So 5 by 6 plus I into, so again 6 LCM. Here 2 minus 3, so minus 1 by 6. So 1 by 6, 5 minus I. Similarly, we need to evaluate the same line integral along another path given in the problem, y equal to x square, which is a parabola. So the second one, consider y equal to x square. That implies we can replace y by x square. So we can calculate dy also, 2x dx, and again x changes from 0 to 1. Now what is this y equal to x square? So if the equation is having even powers of y only, then it is symmetric about x-axis. If the equation is having even powers of x only, then it is symmetric about y-axis. So this, therefore the given parabola is symmetric about y-axis. So here the point is 0, 0 and again the same. So x changes from 0 to 1, the limits we have. So therefore, the given line integral along C, x square minus iy dz, x square minus iy dz, which is equal to along C x square minus iy into dx plus I dy. So this is along x from 0 to 1, x square minus I into y is x square again into dx plus I into dy is now 2x dx. So this is x from 0 to 1, x square minus ix square. So we need to multiply these two into dx plus I into 2x dx. So this is equal to x square dx plus I into 2x cube dx minus I into x square dx minus I square into 2x cube dx. So this is the function to be integrated. So here again on simplifying, x square, here we have the real part, and minus I square is minus 1, so minus into minus plus, so x square plus 2x cube dx plus integral x equal to 0 to 1 I common 2x cube minus x square dx. So that's equal to, now integration x cube by 3 plus 2x power 4 by 4 0 to 1 plus 2x power 4 by 4 minus x cube by 3 0 to 1. So by applying the upper and lower limits, upper limit is 1 by 3 plus 1 by 2 plus here I is there, I into 1 by 2 minus 1 by 3 and the lower limit is 0. That is equal to, so again LCM 6, 5 by 6 plus I into, again LCM is 6, 3 minus 2 now. So 5 by 6 plus I by 6, which is 1 by 6 into 5 plus I. So this is the line integral along the given parabola y equal to x square. So in today's session, we have solved two problems on the line integral of a function of complex variables. So line integral f of z dz along a line or a curve C. Since it is a single integral, we need to transform the variables x to y or y to x or both in terms of some other variable, and then we integrate with respect to one variable only. For that, we use the given curve C. So this is for today's session, and we will meet in the next session. Thank you.